This video is brought to you by the Astor Galaxy Game Room project and course, a tutorial series filled with hours of content and professionally developed 3D models, textures, and 2D sprites. In this course, we will not only take you step by step through things such as creating game systems and mechanics, but also how to use and master lighting and rendering in Unity's various render pipelines. To instantly gain access to hours of high-quality tutorials, professional-level game assets, and much more, click the link in the description and begin your journey to creating the next great game today. Though often overlooked, lighting is an extremely important part of any game's development. It can not only set the tone and mood of a game, but also be incorporated and used in many areas of gameplay and as a game mechanic in its own right. However, depending on the lights you use and the way your scene is lit, lighting and rendering can be the largest factor to a game's poor frame rate and poor performance. So knowing how to properly use and optimize the lights in your game can have a drastic impact on how your games are received by the player and how it performs on a given platform. Lighting and rendering in Unity has come quite a long way from where it once was only a few years ago. From a dark, gloomy, neon-lit street in a grungy city to a glowing setting sun over an open field, you can achieve dramatic effects with the different lights within Unity. Not only that, but ever since Unity introduced its scriptable render pipelines in Unity 2018 as an alternative to the Unity built-in render pipeline, we now have 3 flexible and robust rendering and lighting options: the built-in render pipeline, the Universal Scriptable Rendering Pipeline, or URP, and the Scriptable High Dynamic Range Pipeline, or HDRP. All 3 include real-time global illuminations, or GI, in addition to traditional baked light mapping. This, combined with the physically based standard shader, gives you more power and versatility to easily light more complex scenes. Global illumination is available for the skybox and all the lights in the scene. This means that the skybox, as well as all the lights in the scene, will affect the objects within the scene with indirect illumination as well as direct illumination. Direct illumination comes from the light shining on the objects within the scene, while indirect illumination is the lighting that is reflected or bounced from other surfaces within the scene. Direct and indirect lighting blend together to create a more realistic look for the lighting in your scene or game. Lights in Unity fall into 3 categories: dynamic, baked, and mixed lighting. Dynamic lights are calculated in real time while our game or scene is running. Baked lights are pre-calculated and their information is cached or saved to a texture. This information is then saved within our game, then projected onto a texture or material during runtime. When opening or creating a new scene, Unity will automatically create both a default skybox and directional light that is aligned with the skybox and main camera. In addition to acting as a scene's background, by default, the skybox is also set to provide ambient or indirect light for your scene. If we look in the lighting panel, which can be accessed by clicking the Windows drop-down, then going to Rendering and clicking Lighting Settings, we can see that we have several options and settings for ambient light and global illumination. In the environment lighting section, we can choose or alter our initial environment ambient light source. Additionally, by using the intensity multiplier, we can adjust the intensity of how much we want our ambient light to influence how much lighting it contributes to the objects in our scene. The Ambient Mode dropdown lets us choose whether our indirect lighting is real-time or baked. In order to access the real-time ambient mode, you must first enable real-time global illumination. If this isn't enabled, the ambient mode will be set to baked by default. That said, the baked ambient mode is far more performance-friendly when compared to the real-time options. However, real-time is ideal when creating a game with a dynamic day and night system, as well as for games that have lights and settings that drastically shift within the same scene. Much like the environmental lighting options, the environmental reflection options also allow us to adjust the source of the ambient light that is received and displayed in any object or material in our scene with reflective properties. Along with the light's intensity, we can also adjust the amount of light bounces received in our reflection. Along with being able to change our ambient light source from material, gradient, or color, we can also change our skybox material from the default sky to a custom sky or HDRI material, which is something we'll show you how to do in a later lesson. In Unity, we have two ways to generate lighting data: auto-generate and generating it by clicking our Generate Lighting button. Auto-generate is ideal for setting up and adjusting your lighting within the editor. It offers a fast, efficient way to properly see how your lighting and render setting will appear to your players in-game, and will bake any lighting changes in the background as you edit and manipulate your lighting and reflection properties and settings. Generating lighting by clicking the Generating Lighting button is a much more accurate way of generating and storing your lighting data. However, generating lighting manually takes far longer than doing it by using Unity's auto-generate. That said, it's recommended that you should only enable auto-generate when you are quickly iterating on the lighting while working with a single scene. In all other cases, you should disable auto-generate and generate the lighting data manually. If nothing else, when launching or publishing your game or project, you want to be sure to turn auto-generate off and use the Generating Lighting button to calculate your lighting data, generate your light maps and probes, and cache your global illumination data. By doing this, you will drastically increase your game's performance and ensure that your light always appears correct to the player, since much of your lighting data has already been saved into your game. Something to note, in games or projects with multiple scene editing or additive loading, it's advised that you do not mix scenes with auto-generate enabled and scenes with auto-generate disabled. Whether using multi-scene editing or additive loading, be sure that all your scenes used together have similar, if not identical, lighting settings in the Light Settings window. Don't forget to subscribe and hit that notification bell to be the first to see this and many other tutorials, game development tips, interviews, and free game asset giveaways. To instantly gain access to hours of high-quality tutorials, professional-level game assets, and much more, click the link in the description and begin your journey to creating the next great game today.